Let's now talk about stateful and stateless systems, and also in this regard, stateful and stateless data ingestion. So here in this lecture, this is something that is also of course relevant for the exam. We will cover this theory, and afterwards we will also apply a few practical examples of stateful versus stateless. So first of all, what does it mean, a stateful system? So in a stateful system, the system just maintains the state or the context of each interaction with a user or a client. This means that, for example, when I'm going to a website and I'm logged into my account, I make some changes maybe in my user preferences, and then I go to the website again, I will have this past interaction still remembered. So this is why it is stateful. So here we of course have the benefit that this can improve the user experience because my previous interactions are remembered, and for the later requests they will be still used. And this is in contrast to the stateless system. So here each new request is always processed independently. All of the previous interactions will be completely ignored. So for example, a RESTful API, we always have to give all of the information that we need for our request because the previous interactions, they are not stored. So there's no session data or something that is stored so that we can remember what we have inserted previously. So here, every new request is always independently run. And this can be also related to data ingestion, of course. So in the stateful data ingestion, the system of the load is just remembering what has been done previously in an ingestion event. So for example, we can use timestamps or offsets or also maybe the processing status to, for example, remember what has been loaded already previously. And then we can only load the data that has not been loaded so far yet or that has not been processed yet. And then we have, of course, also the stateless ingestion. This is then just also loading everything again, basically. But this does not always need to be bad, but sometimes we just don't want to store anything. So this can be, of course, a little bit more simple then. So nothing of the previous runs need to be stored. And for example, in AWS Lambda, we can just execute some kind of code that is just then executed based on maybe some event that has happened, and then we can just process the object that is maybe related to this event, and then we can load this new object that was just given by the trigger. This means that we don't need to remember anything of the previous loads. But maybe with, for example, AWS Glue, if we store multiple files in a, maybe some kind of a folder in an S3 bucket and additional files appear, then we might want to use a stateful load. This means that we want to also use the previous information of the previous loads, and therefore we want to make it sometimes also stateful. So how does this work in AWS? We have both of these options available in AWS. For example, in Amazon Kinesis, we can, of course, when we want to stream data, we need to be able to store the data in real time. And therefore, we need to maintain also the state, because otherwise we cannot keep track of what has been already processed. So we need to process the sequence number of what data has been already loaded, and then we are able to resume the ingestion where we have started. So maybe there was some kind of a failure, and then afterwards we need to know where we have stopped last time. So here this is supported with Amazon Kinesis data streams, and also, for example, when we use AWS data pipelines, we can use both stateful and stateless data ingestion. And also in Glue, we can configure the ETL jobs with bookmarks in a way that we can enable some incremental load, so that we can track the process and the data that has been loaded previously, so that we can only process the newly appeared data that has not been processed yet. This is something that we can do by using bookmarks, and this is also something that we want to discuss in a practical way in the next lecture to demonstrate how we can implement a stateful data ingestion using AWS Glue. So that's what we want to do in the next lecture. Let's now have a look at how we can apply this concept of stateful and stateless data ingestion in AWS practically. We have previously already loaded some data from the documents bucket or the documents folder into the target folder, and we have used an ETL job for this. And now it might happen that we might have additional files. So for example, if I see that in this case we might have an additional file, I can just upload this. So I go to upload, and therefore let's assume this additional file would appear. And now what happens if I'm loading the data again? In AWS, if we go to our ETL job and I run this one again, then this will again load all of the data. So we can quickly demonstrate this. I will run this job again, and in my folder, so it has started, yes. So in my folder, if I go into the target, we can see in my bucket under target, there is only this file, and here we have 2.4 kilobits, and here we have this file that has been loaded in March. And actually we can even use Athena, so I can go in this case to the tables, and we remember that when we have loaded this, we have created a table, and here we can see this Parquet file. This is the one that we have loaded through the ETL job, and I can directly go here to the table data to have a look at this data. So then we can quickly see how the data looks like, and again we have no output location. This is something that we need to set up, so maybe I just need to run it again and then it should work. So here indeed we can see that now this data is there. We have those 10 records. And if I load now this additional file, there should be, this is the customers too, in total ideally 21 records. So we have 11 from the first one, and then here we have 10 more. Okay, so this is what we would want in this case, but after we see that this run has been finished in our ETL job, so let me go back to our ETLs, we unfortunately see that all of the data has been loaded again. So let's have a look again at this job and see that once this has finished with the runs, we can see this is finished now. And now if we repeat this query, so we run it again, we will see, and if we now change, of course, the limit, so of course it is limited to 10, so then we see only 10. But now if I run it again, we see 32. So this means the 11 from the first run have been loaded again. So this can be seen if I again maybe sort it. Let me maybe order this. So I just add order by, and then I say ID. And then I see that the IDs from 1 to 11, they all have been loaded twice. And then of course we have the additional rows from 12 to 21. So this is basically the new file. This has been loaded once. But of course in total we would like to have only those total 21. So not loading the first file again with those 11 records. This is what we would like to achieve. So therefore we need to implement an incremental load. And this is something that can be done in AWS Glue by using bookmarks. So how this is done, we now want to have a closer look at in the next lecture. Let's now have a closer look at how we can use the bookmarks to create a stateful data ingestion using AWS Glue. To do this, we can navigate to our job that we have used. And here under job details, we can just configure it to have bookmarks enabled. So we remember we made those settings, and here is also the option for bookmarks. So here it says, specifies how AWS Glue processes job bookmarks when the job runs. So what is done here is when it is enabled, it will remember previously processed data. And when it is set to pause, it will still update the state information. So we remember the state is basically the information of, in this case, what has been loaded and what has not been loaded. And be aware that even if there are some modifications in an existing file, so for example, there are some rows added in an existing file or some data is changed, this will also be processed by the bookmark. So this can be very useful. And of course, if it is set to disable, then the state information will be just ignored. And therefore, if we want to set this up again, we need to load the first file again when this is enabled so that the state information is stored. So then it will be remembered that this first file has been already loaded, and then we can add the second file so that we can see that only this additional file will be loaded. And then in total, we should have only those 21 records here. So let's quickly do this. We will therefore empty here this bucket. So this is our target bucket. We remember we set this up as the target destination. I can just select all of them and then I can delete this. So I just have to confirm that I want to permanently delete these objects. And then once this has been done, I also quickly want to update the source. So under documents, we remember we have those two files. And first we want to, as mentioned, load only the first file. So the state information will be updated. We have loaded this specific file. And then in the second run, we should only load then the second file that we will load or upload here after the first run of our ETL. So I will also go ahead and delete this. So I can again say permanently delete. So now we remember we have only this one file. And since we have just updated, actually, we still need to save it with enabled. So since we have just enabled those bookmarks now, they don't have any information stored yet, but only after the first run. So this means even though we have them enabled, we will of course load this file again because we haven't had them enabled in the previous runs, so no information could be stored. So therefore, let's now go ahead and start our first run after we have saved it. So we can see this has been updated and now we can go ahead and run this. So we remember only this file and also in the target destination, we shouldn't have anything available. So I can search for this. We have our bucket and here is nothing in. So after this job has been completed, we can go here to the run details. Then we will be back and have a look at this. What happens if we upload then the second file and then see how many records are available and if this incremental load has worked or not. So after about 2 minutes, this is done. And now if we run the same query, we should see these first 11 rows. And now we want to, of course, demonstrate the incremental load if this really works. So of course we see in the target bucket, if we refresh, here is this Parquet file. And now we want to add an additional file in the source. So we want to, of course, test if this works. So let me go to the source and here now add this additional file again. So now we can just drag and drop it. I will upload it. And now I will just run the same ETL again. And now we would expect that there are now only those, I think, 21 records. So instead of 32, because this first file would have been loaded again, to have those 21 records. So let's go ahead and run this job again. So we see again after about a minute, this has been now succeeded. And now we run the same query again without any limit, of course. And we want to now see if there are now those 21 records. And indeed, this is the case. So this has worked very well. We can also remove actually this order by. And then we will see that this is now exactly what we wanted. And we have successfully implemented an incremental load. So like this, we have created a stateful data ingestion. Now let's have a look at some important transformations that we have available in Glue. And for this, we want to have a look like an overview again of our ETL process in Glue with a focus on those important transform capabilities we have available. So of course we have an initial discovery phase. So this means that we can connect a data source and from there we extract the data. So here we have different services, different types of data sources available, and then we can use that data that is being extracted to transform it and then load it into our target store. And of course, if we load the data back into our target, we can also decide that we want to update our data catalog. So here we can choose just the way the data should be updated in our data catalog. For example, we want to create a new table for this. And we can also choose the database in our data catalog where the data should be stored. And then once we have extracted the data, we can of course decide that we want to transform the data. So this means that we can do basic operations like filtering the data, joining it, or also doing different types of aggregations. And additionally, we can also have some more complex or some more advanced options available. So for example, we have the transform capability called find matches. This is allowing you to identify duplicate data or matching records in different data sets. So for example, if you have two data sets and the data is not exactly the same, maybe there are some spelling mistakes or it just has a different structure. Like for example, you have a product catalog and you have your own product catalog and maybe a competitor has a similar catalog and you want to find the matches, but the structure is different. Maybe you don't have a matching field like an identifier or a primary key. Then you can use this find matches transform to find those matching records, or maybe you want to in another way clean your data set, find some duplicates because maybe there are some spelling mistakes or the information is not that complete. Then you can use this ML-based, so machine learning based transformation to find those matches or those duplicates. So this can be a quite useful option if we want to do something like this. Additionally, of course, data privacy is very important as well. So when we deal with sensitive information, we can use the detect PII. This stands for personally identifiable information. So this enables you to identify and also manage those sensitive informations. So this can be, of course, important when we have to deal with privacy regulations like the GDPR and so on. And here we can use that to detect the sensitive information. So this will scan the data for potentially sensitive information. And here we can have different options like the names, some numbers that could be personally identifiable information, maybe social security number, maybe credit card details and so on. And then once this is detected, we can configure it to just do various actions on it to protect the data. So here we can use it both for detecting and also then managing it to protect it. For example, we can tokenize it or we can say we want to remove it at all. So here we have different options available to just manage this sensitive information and transform it in a way that this sensitive personal identifiable information is protected. So this is another option that we have available. And then of course it is also possible to just, and actually this is one of the most common use cases, to also change the file format. So here, for example, we have it as CSV file in the data source, but we want to use it and optimize it for analytical purposes. So therefore Parquet might be better. This is a column-based storage. So this is much more optimized for analytical purposes. And of course, any other transformation of the common file formats can be also done. So we can deal with JSON and so on. So this can be also transformed, and this is a very common use case as well. And then after we have done the transformations, we want to load the data into our target data store. So here we can, for example, load it back into a database or Redshift data warehouse, or just simply keep it in our S3 buckets. And then if we want to do it in our S3 buckets, we can also use services like Athena to query the data, and we don't need to move it. So we can just keep it in S3, and we can run queries using Athena or even Amazon Redshift to run queries on the data that sits in these S3 buckets. So this was it about transform capabilities in AWS Glue. Let's now have a look at the feature within Glue, which is data quality. So this helps us to improve the integrity and the reliability of our data. And we want to do this hands-on in practice to understand how this works. So here we can work with a set of quality rules that ensure that the data is as we expected. So we can customize those rules that are then specific to our data. And we can also use machine learning algorithms to identify unusual patterns in our data. So this is a bit different than the traditional rule-based approach. So when something would be missed, this can still catch those mistakes. And we can apply Glue data quality both to data in rest that is sitting somewhere in our S3 bucket, for example, or we can also use it for data in transit in our ETL pipeline. So this is what we want to have a look at now to understand the concept of how this works. So in this case, we want to open our ETL job that we have created before. It's a very simple one. We just connect to an S3 bucket and then we load the data to another target bucket. And now what we want to do is we want to add a new node, and this is now evaluate data quality. This is using this feature. So I'm just searching for data quality and I can already see evaluate the quality and completeness of your data. So we select it and then this will be added to our screen. We can also close this one again. And now what we want to do is we want to connect the data source to this so we can configure it. And here we can also actually directly remove this so we can connect it later on again. Now let's configure this evaluate data quality, and we can see illegal argument. So here no rules are provided. Of course, we want to set this up now. So let's have a look at this rule set editor. Here again, we have the anomaly detection, which would just automatically scan our data and generate observations on our data, but we want to use the traditional approach with the rule set editor. So here we can configure basically conditions. So we can say, for example, column count should be greater than 10. Or we could say completeness between 0.4 and 0.8. And if this is complicated for you, you also have here the helper. So you can say, for example, I want to say column count. If I go here within the rules, I can add those rules from this helper. So for example, I can say, I want to add this one. So of course here, if we now have a look at this, so this one will then on the go have a preview ready for us, and we can see this rule would fail. So here we can see the reason dataset has 7 columns, and of course it is not satisfying our constraint of column count should be equal to 10. Because of course in our data source, we just have those 7 columns. Okay, so this is how it should be. So therefore we would change it to 7, and this is correct in our case. And then if we wait a second, this is again loading the preview, and now it has passed. And we can add now additional rules. So we can say we want to have another one. I say just a comma, and now maybe I want to check the data type. So here I can also add it. And by the way, actually, we can also use it in a more dynamic way. So here, these are just examples. For example, we could also use something like average last 10. So like this, you could create also dynamic rules. And these are just examples. You can just specify the conditions in here also using the code. Or you could check for columns that exist. So here you can use those different types of operations. And now I said I want to use the column data type. So here again, of course, column 1 does not exist. So this would probably fail. And therefore we would just use, for example, the name. And of course, here it is not matching the data type date. So this should also fail now. So it's again being loaded. And now, of course, 0% of rows passed the threshold. So it is failing. So like this, we can now say what we want to do with this result. So therefore, let's scroll down to see what are the options now that what we want to do with it. So we can say we want to also output the original data. So here we have the original data output, and we can also say we want to output the data quality results. So this could then be configured to have it loaded into another bucket, for example. And in this case, we could of course then also connect it with our bucket. And maybe we can have another bucket that is then also using the output of our quality rules. And also we can decide what should be done with the output. So what happens if we, for example, fail? In this case, let's select the main node again. And in here we can say that on rule set failure, we should maybe fail our job without loading the target data. So we can configure that so that the job would then stop. And if it fails, we would not continue. So like this, we can save capacity and we can integrate it later on in our workflow. So at another part of this course, we talk about workflows. So then it would fail and we could maybe trigger another action. So this is something that we can use like this to just manage and ensure the data quality within our glue jobs. All right, hope it was helpful and see you in the next lecture. Let's now talk about the orchestration option from Glue, which is Glue Workflows. So here we can manage the execution of our crawlers, of our jobs, and this is an ideal option to manage our Glue operations. So here we manage the operations from within Glue. This means we have the crawlers. For example, here, this is a crawler. And then we can also have jobs. So maybe we have multiple jobs. And then in between or in the beginning, we can have triggers. So here we can have different types of conditions basically. So for example, we have something that is just getting triggered, the crawler, when the glue job is completed successfully. Or maybe we can have another trigger that has the condition that there's some error in the previous one. This would trigger then another job. So here we can manage the different components from within Glue. So the glue jobs, the crawlers, and also some conditions in between. So these are the triggers basically. And if we want to have a more complex orchestration tool that also uses other services, so in a more comprehensive way, then we can also use step functions instead of the Glue workflows. So this would be the better option in this case. So mostly this is for our Glue components, apart from those exceptions. So here, what you can do is you can create a workflow in a visual way. This means you can just use the visual interface to understand how is the flow of the different tasks. You can configure the different components, maybe the different triggers in between, and like this, monitor also the execution of this entire workflow and combine the different components with each other. And you can also create a workflow from a Glue blueprint, or you can also just build it out manually using this interface or also using the AWS Glue API. This is also something that is possible. So here we have talked already about the triggers. This is very important. Here we can have different conditions included, and those triggers can initiate both the jobs and also the crawlers. So there's no difference basically. And they activate when a job or a previous crawler is complete. So we can configure it that this should trigger when a crawler is completed or also when it failed. So here we have the different configuration options available. And beyond this, each workflow is initiated by a primary trigger. This is a start trigger, and this comes also in different types. So we can schedule the triggers. So these triggers start the workflow at regular intervals. We can define them in a schedule, for example, daily, weekly, or monthly, or also set up any other custom period. We can use, for example, cron expressions to set up such a custom period. We can also just say on demand. This one would just allow you to manually start the workflow from the Glue console. And like this, you could also set up a rule in EventBridge to schedule the workflow or configure it to run as a response to some event. So here you could use then EventBridge to manage this from outside also. So here you have maybe again more complex options available, and this makes it more flexible to combine it with this on-demand trigger. For example, you could also set up a Lambda function that would then invoke this workflow like this. So these are the different options. And also in general, from within Glue, you could also use event bridge event. So this would launch the workflow in response to specific events that are captured by event bridge. And like this, you can set up also an event-driven architecture. And this can be useful, of course, when you want to respond to some real-time events, for example, uploading a file to a bucket. And this can be then managed also from within Glue workflow. So these are the different types. And again, on-demand triggers can be combined with other services. So for example, Lambda functions, or we can use event bridge rules to make this and manage this, trigger this outside of Glue as well. So here we can connect it. So this is Glue workflow in theory. Now let's jump into practice as well. Now let's have a look at the Glue workflows in practice. How does this work? So therefore, let's search for Glue. And here from within Glue, we can also use workflows. So like this, we can orchestrate our different elements in Glue. This includes the crawlers and also the Glue jobs. And we can use triggers to connect those different components, and also, of course, set up a schedule or implement an event-based ETL, for example. So let's see how this works. We start by, after we have selected workflows in here, by adding a new workflow. So we will just add basically a blank workflow, and then we will configure it using the graphical interface. So as a name, we can just say maybe workflow, let's say 1, something like this. Just something very simple. We could also add additional properties like setting a maximum concurrency to set the maximum number of concurrent runs, or we could also add tags and so on, but it is just basically setting up our blank workflow like this. So therefore we go to create workflow, and now if we want to actually configure it, we would have to select it to use this graphical interface. And in here, we start our workflow with a trigger. So we always have to add a trigger first. And if we select it, we could now choose an existing one to use that in here, or we could also add a new one. For example, I would say this is a trigger, maybe on demand, something like this. And here we have those different trigger types. So we can just say this should be run on a schedule. So we say it should be run on a daily or weekly basis, or we even use a cron expression using this custom frequency, or we can just set it up using here this drop-down menu. So this is something that is possible. We also can use events. So then it would just basically use the output of a previous, let's say, component, a job. So this is something we will also see in a second. And we can also use it on demand. So this is what we will be choosing. And if we choose this type, we could also use other services, like for example, Event Bridge. We could set up an Event Bridge rule to also trigger this workflow from Event Bridge. Or maybe we use a Lambda function to invoke this workflow. These are things that are possible also with this trigger type. Or we can just use Event Bridge event from within here as well. Then we can also manage it from within here. But in our case, we will use, as mentioned, the on-demand option. So we will add it and then we have it started. So now we could run this workflow like this from within here on a manual basis. And now if we want to add additional components, for example, we want to run our jobs, then we can add here the additional node. So here I can now add either jobs or crawlers as we have mentioned. I will just choose our first ETL job. So I will just add it in here. And now if we want to add additional components, as I have mentioned just a few seconds ago, we would have to add an additional trigger. So if I select this ETL job, I can now configure a new trigger that is using the event from this job. So whether this has failed or has been completed successfully, I can now add a new trigger. So I will do that. And here I have this trigger type event selected. So the trigger logic could be, for example, start after any watched event, or after all watched events if we have multiple events that are connected to this. So I could have maybe 5 different ETL jobs, and then after all of them have maybe completed successfully, I can have this trigger being activated. In my case, it doesn't matter, I have only one, so I will just leave it at any. I will add it, and of course, let's add also a name. So let's say this is second trigger, maybe like this. We can add it. And now after that, we could, as we have mentioned, add additional jobs so that we have additional nodes here integrated. And also we can add something that should happen after that. So what should this trigger actually trigger? So I can add, for example, now a crawler. So I want, after this job has been completed successfully, I want to add some crawler. So here we can just choose any of those crawlers, it doesn't matter. I will add it, and then this has been set up like this. And if I want to have more information on that, I could select it. And in here, I can see that this is the trigger logic. So after any watched event, and in this case, it is watching just this previous job, and it is triggering when it is succeeded. If I want to change that, I can also say that I want to select this one, and in here I could say that I want to edit the watched event. So here I can say this should be changed to maybe failed, and if I do that, I would update basically this trigger. So this is the event that would be sent, and here if I have now this trigger selected, I can see this would be watching for the failed output. So in this case I can modify it from within here. I will change it back to the succeeded. So I go to the watched event and I change it to succeeded, updated, and then it would be updated also in our trigger. And of course, I can also add additional things. So I can say I want to add additional jobs to trigger. So then I would here have another node. Or I can say I want to add additional jobs or crawlers to be watched. Then this would just add a node in here, or I just use the visual interface. So here I could also add maybe another crawler like this, and then it would be also added in here. So this is how it works. And then from here, I could run it either on demand. So I can say I want to run the workflow, or maybe use an event bridge rule to trigger this, or we can use a completely different trigger also, so we can run it on a schedule, for example. So I could say I want to remove this trigger, and now maybe I want to add some other trigger. So I want to say maybe I want to add a new one, and now this should run on a schedule. So maybe this is on a daily basis. I add it, and of course let me give it a name. So let's say test trigger. I will add it, and then this will be added in the beginning. So here it is. And we now want to connect this one actually. So this means I select it, I go to actions, and I say add jobs to trigger. I select this, and here I have the jobs. So I will select this one, and then it connects it to our job that is already part of this workflow. So sometimes it is a bit confusing in this visual interface, but basically it is very simple, and we can just like this set up our workflow. In our case, I will just go ahead and actually delete this. So because I have set this up on a schedule, and I don't want this to run on a schedule, so that we make sure we are not incurring any cost here, I will go ahead and delete this workflow. So I hope this practical demonstration was helpful, and see you in the next lecture. Now let's talk about the different options for our glue jobs. So here we can use different types of underlaying engines, and I'm referring to this as different job types. So when we create our glue job, we have different options of working here with glue. So we can use the visual interface. So here we can just drag and drop. And if we are doing this, the engine that is used under the hood will be selected automatically for us. So we cannot change that. And this will be just set automatically based on the types of data sources we have selected. So usually this is just Spark. So here, this is is what is used under the hood usually for Glue, but we can also use a notebook. So we can do some data processing maybe interactively to maybe just experiment using also here a notebook. And for this, we also have different types available. So here we could choose it. And the same is also true when we author our script ourselves. So of course we know when we create a job in a visual way, then also under the hood there would be the script generated for us. But we could also, if we want, do this just completely from scratch ourselves. And in this case, we could also have more control to select, for example, a different engine. Maybe we have some lightweight task that is just requiring us to use Python shell. So this can be a cost-saving method. And here we have also Ray, which has been newly added. And also we can use Spark. So let's quickly talk about them and start with Spark. So Spark is the default usually. So this is commonly used for the different types of large-scale data processing workflows. So here we just use Apache Spark under the hood. So here we use those distributed computing capabilities of Spark. And of course, this is very suitable for handling big data workloads. And here we have the option to use from 2 DPUs up to 100 DPUs. So this is a lot. And the default here is 10 DPUs, which actually is already a lot. But again, this is for large-scale data processing. And 1 DPU, by the way, this stands for data processing unit. And this just represents the processing capacity. So here we use that to execute our ETL jobs. And here each DPU includes 4 vCPUs and 16 gigabytes of memory, and we are built based on the DPU hours. So here, if we want to scale this down, we cannot do that less than 2. And also we have the Spark streaming ETLs. So this one can be used for analyzing and processing data in real time. And here we can also react to events as they occur. So we do this in real time. And here we work with streaming data sources like Kinesis data streams or Kafka. And here we have the same DPU options like in the Spark jobs. And again, the default here is 10. Additionally, as mentioned, we also have the Python shell jobs. So here we use them more for simpler or more small-scale data processing tasks. So when we don't need to have this power of the distributed capacity of Spark, we can just use Python shell jobs. And here we can just run Python basically in a managed environment for very, very lightweight tasks. And the reason for this is because here we can just use much fewer resources compared to those very large-scale Spark ETL jobs, because here we can configure it from starting 0.0625 DPUs up to 1 DPU. So you see, even the maximum is actually less than the minimum of the Spark ETL job. So for lightweight tasks, we can save a lot of cost here when we don't need to have this much power with the Spark ETL job. So then this can be a good option. And lastly, we also have the Ray jobs, which has been newly added. So here we can use the Ray framework, which is an open source framework where we use Python and run it in a distributed cluster in a multi-node environment. So here basically Ray is Python native. And if you want to use Python, you are familiar with this, maybe for machine learning or data science, then you can use your familiar skills in Python, all of those frameworks and libraries, and bring it to Glue and scale them for your huge data sets. And you don't need to modify the code so much because it is Python native. So here you have this option available. So oftentimes it is useful when you want to use something that is familiar to you in Python, maybe for machine learning, or maybe you have some parallelization. So maybe you want to apply multiple transformations in parallel, or you want to run the same Python workload on hundreds of data sources, or maybe do something on a huge scale for machine learning ingestion, parallel batch inference on your data. So these would be then specific situations. So machine learning, for example, where you can also now have access to this this Ray engine and run this also in Glue. And here in these Ray jobs, they are run on the new Graviton-based EC2 worker types. So this is a little bit different than Spark. So those new Graviton-based EC2 worker types, they are only available for the Ray jobs. So again, this is suitable also for large-scale parallel processing tasks. And then we have also the execution types. So we have, of course, the standard execution type. This is just the default, but then we have also added now the new flex execution. So this type is just a cost-effective alternative if we have less time-sensitive ETLs. So sometimes it doesn't matter when it is executed. So in this case, we can save cost. So in this case, the jobs are just queued and they are run when the resources are available and therefore may start with some delay, but it can then therefore save us cost. So for example, here we can say we want to have a weekly data transformation job and therefore we don't need to have a specific time and therefore we can use then in this case the flex execution to save some cost. So these were the different properties and how we can configure our Glue jobs in different ways. Now let's quickly demonstrate this in practice as well. So we just briefly want to go over how this would look like here in practice. So therefore let's navigate to our existing ETL jobs. We can see that we could create an ETL in this visual editor. And here we remember that here the engine would be automatically set for us based on the tasks and the data sources of this ETL. So we remember we have created this job before. And here if we would have a look at this, we could see under the job details that here we see the type and this is automatically set for us. Here we could of course make some changes, like for example adjust the language that is used or the worker type. We could increase it, for example, or have it automatically scale the workers. Here we remember we have the number of workers. This is basically the number of DPUs and this is what we are built on. So basically the hours of DPUs we are built on. And we also remember that for this type of engine, we cannot use less than 2 DPUs. So if I would want to change this to 1, and if I would try to save it, I get the error message that here the minimum allowed value of number of workers is 2 in this case. So therefore, we could only use 2. And if we would want to use less, we have to use a different type. So we could use, for example, a Python shell job. This would be an alternative in this case. And additionally, we remember also we can use the flex execution to reduce cost for less time sensitive jobs. So in this case, it would be maybe executed a little bit later than we have defined in our schedule, but therefore we could save some cost. So we could just also check this flex execution in here. And additionally, if we want to choose this manually, if we want to write this out also in code ourselves, because we remember that if we do this in this visual editor, of course, under the hood, this script would be just generated also for us. So it would be also using this script, but we just define it in a visual way here in this visual editor. And therefore, if we want, we could also use the script editor. So here I could define the engine myself. I could say, for example, I want to create a Ray job and then start from fresh to write the script in here as well. So this was just a quick demonstration on how this looks like in practice.